Why you think you're using React only? Your dashboard page starts like this. Use client, uh, one code, semicolon. This tells Next.js, don't render this page on the server, only run it in the browser. So we I actually don't use the server-side rendering because of this line of code. This tells Next.js, don't render this page on the server, only run in the browser. So inside that file, so actually Next.js is a server. You can use Next.js as a server rendering server, but you can also just choose to use its front-end features, just like my LiveKit app. So inside that file, you use effect to listen to Firebase. You use real-time subscriptions on Snapshot. So the React code or the React word that's responsible for listening to Firebase is use effect. The real-time subscription that load data on demand is the on snapshot. You do client-side routing via link from next/link. So the client-side router we discussed in Angular before are being done here via link from next/link. Browser handles everything after hydration. This behaves like a React SPA. So, how are you using Next.js? Even though most of your logic runs like a React SPA, you still benefits from Next.js in several invisible but important ways. First, file-based routing instead of React router. So remember we saw Next.js/link because we use a file-based routing instead of a React router. Remember in Angular, we use the Angular router, but here we actually use a file base. You did not write browser router, then next router, then route path equal code dashboard element equal dashboard, which is how you would route it in React, then closing browser router. Instead, you created folders app/dashboard/page.tsx, app/login/page.tsx, app/patient/room/page.tsx. Next.js automatically becomes the router because of this folder structure. So this is what the next/link. So even if you think you're our client routing, the route map is generated on the server from your folder structure. So the routing is actually generated from the folder, which is this structure. So in Angular, you actually does that in the front end. So instead of executing that in the front end, since we're using Next.js, we're routing it through the back end, kind of like the back end. Server-side API routes, you're using them everywhere. Inside app/API, you have app/API/create-room/room, app/API/cleanup-sessions, app/API/doctor-access, app/API/token. These are all Next.js backend functions like Express APIs. So remember, Express is actually how we route it in the blogging app. This is also how we route it, but now we are actually routing it using Next.js. So these are all Next.js based function, backend function like Express API. Here's the code: export async function post with the parameters request, and then open semicolon, and then close semicolon, then server only code. These run on Vercel server, not the browser, because I actually implemented or deployed my front end to this Vercel. Therefore, it actually ran on Vercel server, not the browser. My browser I just use to access that web application. It can use secret keys like Firebase admin keys, LiveKit secrets. This is actually how I integrate my LiveKit and Vercel. I use the Firebase admin keys in this integrated Vercel and Next.js. And I just put the Firebase admin key LiveKit secrets in the environment variable, and that's how I integrate it seamlessly. There's no need to like any complex code. You just need those keys to be able to access that in the backend, and just simple like calling of the API or the components. React alone cannot do any of this. React Router cannot provide a backend. Next.js providing your backend. So I actually use Next.js I use backend instead of just a front end. So my Vercel acts as a server, and Next.js is also a server. Now I access the Vercel through browser. So that's kind of like the front end I have. So mostly it's on the server or backend server, because React cannot do those alone. Next.js provide the backend. Middleware plus edge functions. You have middleware.ts. Import next response from code next/server semicolon. This runs before routers and protects pages. So this import in middleware.ts run, and actually is the protector from browser to Vercel. Only possible in Next.js, not React SPA. Fourth, Next.js also offers better bundling and optimization. Even with use client, Next.js splits your JS into chunks, optimizes imports, lazy loads page bundles, compresses and tree-shakes build automatically. So it's being handled for us, or for my LiveKit app, by Next.js. It split the JS of the React code in the front end. It optimized the imports. It lazy load page bundles. So each page on the backend are being lazy loaded in the Vercel server. React SPA does none of this by default. Automatic static assets plus deployment plus routing. Your public slash folder automatically becomes static hosting. Vercel automatically optimize your build because it's Next.js. So the public folder I have in my app automatically becomes my static hosting for Vercel for related to deployment and routing. And Vercel automatically optimize my build when building this front end along with these node modules, because it's actually using Next.js, because there is a repository for Next.js and Vercel that allow them to integrate seamlessly. Final summary: feature, routing, React SPA, React Router, you're up with Next.js. File system routing, Next.js. So the key with routing with Next.js is the file system. Feature, backend, React SPA needs Express or Node. So remember, in full stack blogging app, we need an Express API and a Node for implementing backend. However, for Next.js, it's a built-in API routes. So Next.js provides our backend. Auth middleware, React SPA needs custom server. So you need a custom or another service for acting as a middleware for authentication. Now with Next.js, you have middleware.ts, which is a Next.js middleware. Secret keys, React SPA is not safe in browser. So imagine requesting your full stack blogging app with the keys in the browser console. So for Next.js, it's handled on the server, which is in Vercel. You just need to enter that in there, environment variables. Rendering choice, React SPA, always client. So it actually renders that React renders the front end code in the client, but in Next.js, we chose use client, meaning we still use some of the React feature, which we bundle everything at once, but at the same time, for routing, we use Next.js. Important takeaway, you're choosing to render on the client, but you're still using Next.js features everywhere else. You're using Next.js as a secure backend, plus file router, plus optimized bundler. So since we are not storing keys in the front end, unlike implementing our backend in the front end or in React, we actually use Next.js for secure backend and a file router, file system router, and optimized bundler at once while still writing a client rendered app. So that's the advantage of our LiveKit app. First, the package.json in your screenshot. What does it mean? You saw name colon at next sw-win32-x 64-f-msvc, next line version colon 15.4.6, next line repository colon open semi-curly bracket, next line type colon git, next line url github.com/versus/next.js, next line directory colon create slash napi/nvm/win32-x64-msbc. Does this mean your app is using all Next.js source code? No. So it doesn't actually use that Next.js integrated with Vercel. It only means a small compiled part of that code, the SW compiler, was downloaded. So that's what we see with package.json. This is like installing Chrome. You're not copying Chrome's source code. You're downloading the compile bit, all the required data on demand. What is SWC? It's a high-performance Rust compiler Next.js uses to transform JavaScript, compile TypeScript bundle modules. So this is how we actually optimize bundler. We convert that React into a Next.js and Next.js to sequence of chunks that we can transfer to the actual Firebase function. It's not your framework logic, it's a build tool. So are you using Next.js? You use Next.js only as a bundler or runtime because your app currently does not use SSR. So we just use this. So that's entire part of the code of the GitHub repository of Vercel and Next.js. We're optimizing or we're using the bundler or runtime in that. But we do not use a server-side rendering because we use a client-side rendering, which we bundled mostly at first, and we just listen on demand. Does not use server actions, does not use server components. So we actually use do not use server action and we do not use server components, though we route it via file system router of Next.js. So you're using Next.js like Vite, CRA or Parcel, and Express to run browser-only React app. You are using React SPA. You're not using Next.js SSR. So the Pareto 80% behavior of your LiveKit app, 80% of the time, this is what happens. Stage 1. Browser downloads a single HTML plus the JS bundle provided by optimized Next.js bundle. Second, browser starts running React. So since it sent the bundle, Next.js and a single HTML React that serve as your front end, the browser will now interact with those React and then just listen on demand to Firebase. Third, React router shows different pages without asking the server because a lot of the pages in the front end are served at first load. Fourth, data is fetched as JSON from Firestore. So it's parsed and encoded and decoded via Firestore. Fifth, LiveKit handles audio or video via WebRTC binary through client.js. So that client.js, we actually execute that using React and convert it to client.js, which then converted to a sequence of bytes and then to WebRTC binary. 6 UI updates purely in the browser, no HTML from the server. Conclusion, your app is a pure SPA single page application. SSR versus SPA in one sentence. SSR, server builds HTML for every page. SPA, browser builds HTML using JavaScript. So the key is the HTML, SSR and SPA. In SSR, you build HTML every page from the server, while SPA, you build the HTML via JavaScript. Our LiveKit app is equals to SPA. Why LiveKit plus SPA makes sense? LiveKit is real-time, low-latency media, fast UI changes, fast state updates. So since we're using WebRTC, it makes sense to use an SPA. We also need a fast UI change and fast state updates. SSR would be pointless for live media streaming. Imagine rendering HD video on the server and sending HTML. Impossible. So the reason why we need the fast state changes, which React and XJS provided, and fast UI changes is because we are using a video app. So, or we're executing a video app via LiveKit. What about middleware? Runs before routes. When someone said this runs before routes and protects pages, this means middleware runs before React see the route. So it kind of like intercepting the React whenever the React, before the React see the LiveKit file system routes. Example, authentication check. You have a request to middleware, then decide allow or block, then SPA run if allowed. Middleware is not equal SSR. It doesn't render HTML. It only allow or deny access or redirect. How routing really works in your LiveKit app. PHP or traditional server routing. Browser to get or patient to server builds HTML, then returns full HTML page. Your SPA routing, browser loads index.html. Once React takes over, URL changes without page load. So the HTML are built from React or JavaScript. Data loads separately as JSON. This is how we load data on demand. Firestore get patient/123 returns JSON. React displays it. How next.js SSR would look. So here's the code. Export async function gets server side props. Open and close parenthesis. Open curly bracket. Next line const patient equal await db dot get by id. Argument 123 semicolon. Next line return. Open semi-curly props colon open semi-curly patient closing semi-curly closing semi-curly semicolon closing semicolon. Here the server sent HTML with data. You do not have this. Full stack summary with technologies, layer, UI rendering, technology, React SPA, what data format, JavaScript, DOM, page routing, React router, your technology, React router, what data format, browser history, data fetch, your technology, Firestore SDK, what data format, JSON, layer, media, your technology, LiveKit, WebRTC, what data format, encrypted binary packets, layer, build tool, your technology, Next.js SWC, what data format, compile.js bundles, layer, transport, technology, TCP or IP plus UDP, or UDP first before TCP IP packets, binary blobs. What you should study next, priority in order. First, React router, deep dive. Second, Firestore client, SDK and caching. Third, WebRTC basics for LiveKit understanding. Then learn SSR or Next.js server components, not before. Optional later to connect everything. TCP or IP illustrated to understand network latency plus packets. WebRTC internals for streaming. Final super simple summary. You are using Next.js as a tool, but your app itself is a React SPA that fetches JSON and streams WebRTC directly in the browser. So you're using Next.js as a deployment or runtime, not an SSR engine. Next.js is two things at the same time. Next.js can be a framework, description can render pages on the server, SSR, SEO, caching, streaming. It can also be runtime or builder. Bundles React, splits code, deploys serverless API routes, handles routing and assets. Your app is only using the runtime part. You're not using SSR page rendering features. So you're using Next.js but only as web server for static assets like the CSS compiler, SWC, router container, code splitting optimizer, host for API routes, room creation, AI summarization. That's the Vercel Next.js. Deployment edge runtime, Vercel or /node. Think of Next.js like a bento box. A bento box has many compartments. Next.js contains SSR, feature pre-render pages on server, API routes, serverless functions, static files. So actually, we use a serverless function, which is the .tsx rooms that we write and deploy in Vercel. Static files, serve.js bundle and CSS. So that's the assets. Client SPA mode, React running entirely in a browser. So Next.js also provides this option for React. Build tools, SWC, building, chunk splitting. Edge runtime, optimized fetches caching. You're using everything except the SSR sushi, but it's all the same bento box. So what exactly happens in your app? First load, Next.js sends an HTML shell, no SSR content, then JavaScript chunks, then to Firebase, to LiveKit, then your React components lazy loaded where needed. After that, all navigation and data fetching happens entirely in the browser. Firestore listeners, after that first load, it actually load data on demand or happens entirely in the browser because it's now connected, like the session has been built, kind of like a WebSocket. Firestore listeners, React state updates, so that's the technology that made that session persistent. WebRTC streams. Now auth, room creation, AI summary, use Next.js API routes. So that page.tx all use Next.js API routes. These routes are server-side. Example, export async function postrec. So you might think that .tsx is client-side, but it's actually a server-side. You don't SSR the pages, but you do use Next.js server behavior for backend logic. So each pages are actually not server-side rendered because it's rendered at the first load. But for the logic, we actually use Next.js server with Vercel. So your architecture is React SPA runs in browser, to Next.js API routes, to Firestore or LiveKit or OpenAPI. Key point that unlocks confusion: SSR is optional. Routing is not equal SSR. Just because Next.js control routing app / doesn't mean it renders HTML on the server. The moment you mark a component, use client, use client semicolon, you're opting out of SSR for that entire sub-tree. You choose SPA mode. Your pages are 100% browser rendered. Your data fetching is client side. So the pages are the only one that's 100% browser rendered. Your data fetching is client side. Your video is peer-to-peer WebRTC. Your listeners stream over HTTP/2. React SPA with Next.js runtime. One sentence summary: you're not using Next.js to render HTML on the server. You're using Next.js as the platform that bundles host, routes, and provides server functions for your SPA. When will you actually use SSR? If you later add SEO landing pages, doctor profile, public pages, blog articles, public schedules for doctors. Then you would switch some pages to export async function, generate metadata, or export async function, get server-side plots, or use server components by using use client. So some of this feature will be now implemented in your Next.js as a server-side rendering. But your LiveKit call UI should always be client-side. SSR cannot render real-time audio or video. So you will have to keep that LiveKit as a server-side rendering. Because server-side cannot integrate with the LiveKit app or WebRTC.